You have a disgusting foot fungus that grows for a certain number of days and then dies. The number of spores is growing at the rate ds over dt equals k, some constant k, over the fourth root of t minus some other constant j, where s is the number of spores and t is the number of days. We're told when t equals 0, you have not yet begun to grow nasty spores. That's telling you your C value is 0 after we integrate. We're then told that after 12 days, population is 22, and after 16 days, the population is 24. So we want to know what's the maximum number of foot nasties that you will have, and how long until your foot is clean again. Okay, well, when we're given a derivative like this with unknown values, we need to integrate and then plug our points in to find our unknown values. So we are integrating the function k times t to the negative 1/4 minus j, and we're integrating with respect to t, the time. When we do that, we will get our function s, the number of spores with respect to time, equals t to the negative 1/4, add 1 to negative 1/4, negative 1 plus 4 is 3, so we're getting t to the 3/4. We need to then divide by 3/4, which is the same as multiplying by 4/3. So I'm going to put a 4/3 coefficient there, and I still have my constant k hanging out front. And then minus j becomes j t. And then I would have plus c, but I know that my constant of integration is 0 because there are 0 spores at time t equals 0. So c is 0. Now I have 2 points, so I need to plug in. I know that after 12 days, the number of spores is 22. So I get 22 equals k times 4/3 times 12 to the 3/4 minus j times 12. And I also know that after 16 days, the population is 24. So 24 equals k times 4/3 times 16 to the 3/4 minus j times 16. So I'm going to write this as a matrix in the form of 4/3 times 12 to the 3/4 is my first term in my k column, and then a minus 12 in my j column, and then 22 in my equals column. And then second row will give me 4/3 times 16 to the 3/4, and then a negative 16 for j, and a 24 in my equals column. So I'm going to enter this into my calculator and do an RREF to find the value of k and j. Should find that k is roughly 6.705 and j is roughly 2.97. So I have my values of k and j, and I want to know what is the maximum number of foot nasties you will have. Well, if there's a maximum number, that means there's a maximum value on a graph that I can find, and how long until your foot is clean again. So how long until there are no spores. So this tells me I need to have some sort of graph that's concave down that's going to give me a maximum and then another 0. So let's graph this equation on our calculator and see what we can find. So after playing with my window for a while, eventually I found that 0 to 100 gave me a decent window. So I did x min 0, x max 100, and then I hit zoom fit, and it gave me a graph that looked like that, essentially. And I want to calculate this maximum value, because that would be the maximum number of foot nasties that I have, because again, your y value is the number of spores. So calculate that maximum, And you should find that you will have roughly 25.716 foot nasties. And then to calculate how long until your foot is clean again, until you have 0 spores, well, that's going to be that 0 right there. So calculate that 0. So second, calculate 0, left bound 0, right bound 100. Guess, put it close to 100. You will get clean foot after 82.096 days. So you're going to have a stinky, nasty, disgusting foot for quite some time.